So 0.36 molar. We wanted moles of B per liter of solution of B, right? We started with 0.1 moles of A for every 1 liter of A. Oh, sorry. We want moles of A, that's our unknown here. We have a known of 0.1 molar of B. We have 1 liter of B. It required 18 milliliters, which is 0.18, whoops, 0.018 liters of B. That gets rid of those units. Now we're in moles of B. We want moles of B to go to moles of A. And then we have moles of A on top, so we just need liters of A. How many liters of A did we put into our reaction here? Just the 10, right? This doesn't contribute because it's just water, 0.01 liters of A. So now we have liters of A on the bottom, moles of A on the top. This relationship here, it's our stoichiometry, 2 moles of A to 1 mole of B. Okay? Very good. So, a calculation from a titration. What do you do if you're performing a titration and you get these results? 1, 16.35 milliliters. And also, how many significant figures should we be able to get from these burettes? 4 significant figures, right? Do I have to explain that, or everybody okay with that? 16.35, 12.21, whoops, this is a 2. 11.18 for 16.31. Now what do I do? Let's try that again. These are our different runs. What do I do now? What's that? Redo it. That's right. You redo it. Because this stinks, correct? So you have to make sure you're confident in the color change, right? You have to make sure you're aware of how the system is working. All right? You're not in a hurry to find out if this person has cancer or not. You want to make sure you know. Right? That's right. So, make sure that you're confident and aware of the parameters that are influencing your titration. Okay? If you wanted to, you could make your own standard or own example of an unknown, but I don't think you will need to get to that point, but the materials will be available to you if you wanted to do that. But all right, so you need to make sure that you get some values. What if I do it once, 16.31, do it twice, 16.32. What do I do now? Do it again. You have to do it at least 3 times, right? Okay? All right. What else? I think that will suffice for titration, right, and identifying concentrations of unknowns. We just did a calculation where the unknown was a solution, right? That was like in lab 5, correct? We had an unknown solution of tap water and of ocean water, right? We added water, deionized water, to those samples sometimes, like the ocean water. Why did we add the water? Why did we add tap water to our ocean water sample? What was the volume of your ocean water sample, remember? It was like 0.5 or 0.25, right? Small volume. So why did we add water, DI water? There's no ions, so that's why we use DI water. Why don't we just use the 0.25 milliliters? Increase the volume. So why does increasing the volume help? Okay, easier to see the color change, right? Did you get to sign up already? Yeah. Easier to see the color change. All right. What else does an appropriate volume do when we're performing a titration? Easier to stir. Did you get to sign up already? Why don't you come sign up? Easier to stir. And what does that mean when we say easier to stir? I mean, the stir bar is going to just spin through anything, right? But what's it helping with? Okay, it dissolves stuff and mixes it with drops fast. Did somebody else say something here?
Decrease the splashing?
Yes, decrease the splashing. That's what we don't want. We don't want splashing because if your unknown is 10% of it up on the edges, right, and your color changes, but then you haven't got that stuff, you don't get it. Do you have a question? You raise your hand? Oh, recognizing that significance. Okay, very good. All right, what else do we got? When you come here, you're going to receive a little piece of paper. The paper is going to have steps, things that you have to do, and then the back side is going to have a space for you to draw figures and write it up. All right? You'll probably need to use Excel to create the figures and answer the questions, but you're not going to actually paste an Excel graph into there. You're just going to draw it by hand. Okay? You're going to want to make sure you know how to draw a good figure, right? What are the components of a good figure? Title. What did we say about the title?
That is for nerds.
What's that? What?
Nerds.
It's for nerds. I don't think I've said that. Did I say that?
You said that titles
Aren't cool. Nerds are not necessarily not cool. So that doesn't mean you're no title, no cool. But that's right. Titles are out right now. They'll be back at some point, just like all fads. But so if you have a title, that's not one of the important components. What are the important components? Labeled axes, right? I'll say absorbance at 810 here, for example. Concentration, very good. A line and a equation, if appropriate, right? If appropriate. Okay, what else do we need to get a good, all right, a figure caption. It starts with figure 1, ... Right? And then what? At least 2 sentences, 2 complete sentences. All right? Hopefully those sentences are not about your mom's apple tree at home. Hopefully that relates to this. But at this point, I don't care. Just as long as you have 2 sentences, I'll give you credit for trying. Okay? But that's the idea. It's the truth, right? I don't know that you guys really understand what's going on there. But the 2 sentences indicate to me that you recognize the importance of giving a good caption. It's so funny. So there's a couple of journals. Energies is one of it's called, and the Journal of Power Sources. Every once in a while, well, you know, any journal that publishes papers receives work from researchers and then looks at the work. They have their editors look at it for grammatical and different issues, and then they send it out to reviewers. And they choose 2 reviewers. The reviewers look at the papers and see if they think that this is a good paper, right? The editors don't know the content necessarily, whether the content should be good or not. But the peer reviewers aren't paid. You don't get paid to do that, right? You are independent of it. You just look at the paper and say, yeah, that looks okay or whatever. And sometimes you get papers that don't follow the standard. The figure caption is just like a couple words, right? And those types of papers don't get accepted, right? They don't get accepted. They get sent back, and if the editor and the reviewers have patience, then they'll allow them to resubmit. But usually there's like, no, sorry, not going to deal with that. Okay? So, good complete sentences so that somebody can look at this and know everything there is to know about your work here. All right. What else do we got? Okay. Devotional still starts at 11, right? Okay. So, anything else we got? Titration, we were talking about titration. Oh, I wanted to make sure that you guys understood. We worked with a titration where we had well, this is the solution. We had a solution, unknown, and we also worked with a titration where we had a powder, unknown, right? And if you have a powder, then your value, your unknown, should be reported in terms of what for concentration? How are you? Mass percent. Mass percent. If it's a solution, we want what? Well, parts per million is an option, but molarity is the love of chemists, right? Why is molarity better than parts per million? Yeah, you know the moles of the material. If somebody says parts per million, thank you, now I get to go do another calculation to find out what the molarity is, right? So, okay, I think we got it all. Any other questions? If you want to stay here and get help with anything, that's fine. Okay, so sorry, I'm sure there's more people that contributed to the conversation today than these people, but we just needed to try to minimize that line a little bit.